Hi, I'm Xiaohan Ding. I'm very happy to show my recent research. My research topic is analysis of the influence factor of COVID-19 based on the game theory and dynamic model. Firstly, I would like to introduce some of my research problems. Under the global COVID-19 situation, different social decisions reflect the benefits for different groups. For example, whether citizens stay at home follow the policy issued by the government. The topic of my research focuses on analysis of benefits and the conflicts between the government, housing department, and the citizen during the future time. Firstly, my research idea is to dig out some current attitude between the government and the citizen based on the machine learning model, and analysis of future decisions based on the game theory. The final result I really want to get is the impact index of a public opinion and national policy. So I need to analyze the factors that influence the public opinion over time and find the index of the correlation between them. Firstly, I use the K-in method. Well, it is a relatively simple classification algorithm, but because my dataset is relatively complex, it will cause additional calculation time overflow. So I re-examine my problem. My problem is not only limited to the classification. I also need to find some reasonable influence factor for the result. So I use the classification based on the association rules. At the same time, for some special dataset, such as the relationship of the with the public opinion for White House or economic, they don't have very strong connection with national policy. So I found that SVM can work better for those simple datasets. In the end, I got my final result. In order to improve the confidence for my final result, I propose using business theory to find the confidence. Here, I call it to association verification. Now, I will focus on the perspective of game theory. Three players evaluationary game theory includes the construction of the game theory model, the derivation of the dynamic equation system, and the calculation of the comprehensive strategy by Jacobi matrix. And the Jacobi matrix is shown in figure 1. I finished the model construction with general payoff matrix of model with CG, MH, and CR. So CG here is central government, and CR is the citizen here. And then I prove the model derivation and the verification. In this process, I propose a totally 6 hypotheses. In order to describe this player's behavior, the hypothesis is very important. So each player has positive and negative behaviors. For example, CG here has X and 1 minus X. So according to the permutation and combination, I finish each corresponding proof and the derivation for each hypothesis. In the end, according to the replicate dynamic equation, the mathematical expectation for each player benefits was obtained, and I got the final Nash stable state. I analyzed two interesting Nash stable sets here. In order to simplify it, I write a set to 110 and 111. The difference between the two sets is the time period. With the continued growth of the COVID-19, simulation based on recent data has shown that the system cannot able to improve the benefits for the citizen, and it needs to reduce the benefits for citizens' behavior to 0. And at the same time, we also need to maximize the intensity of the government policy to achieve the stable state, which is 110 here. Although I simply use the Boolean variable in the presentation, but in my report, there is a complex set for the parameters, such as the right side picture shows. So in the future research, I hope that my model has a stronger generalization ability, because this is not just a feedback for recent research. I think this kind of research thinking can bring lots of inspiration to the society, and hope that in the future I could continue to start machine learning algorithms and improve my research topic.